Some more questions on conditional probability. So question is that you have two dice and first dice is 3. What is the probability that the sum of the dice is 8? So given the first dice is 3, the possible options, so you have two dice, we can just create a dot diagram. 1 2 3 4 5 6, 1 2 3 4 5 6, and a dot diagram. So two dice, and then we know that the first is 3. What is the probability that the sum of the two dice is 8? So what are the probabilities that the sum of the two dice is going to be 8? So there is none here. This one, 5 6 7 8, so this one, then 4 and 4 is going to be this one, then 5 and 3 is going to be this one, and 6 and 2 is going to be this one. And we know that the first dice is 3, so this is our target. This is the only one which is 8, and each of them have the same probability of occurring, so this is going to be 1 by 6. Now probability of, let's just say, E is the sum of dice is 8 and F is that the first dice is 3, and we want to know probability of E knowing F. That is going to be E and F divided by probability of F. Probability of E and F is so you can just calculate this based on this, that this is your new sample space, because the F is the first dice is a 3, so there are 3 possibilities, and out of which this is your event. So this will be 6, 1 out of 6. But we can also do it in this manner, in which we are doing is probability of E and F both occurring divided by probability of F occurring. Now what is the probability of F occurring? The probability of F is the first dice getting a 3. So what is the probability? The probability of F is basically 6 out of 36, or 1 out of 6, because there are 6 of ways which can get it. Now, and what is the probability of E and F both occurring? So in E and F happening is just this. So this becomes 1 over 6 divided by 1 over 36, because this is just one event out of this whole space. E and F occurring is 1 over 36 divided by 1 over 6. That is 1 over 36 times 6 over 1, or 1 over 6. Next question is Joe is 80% certain that missing key is in one of his pockets. And he thinks that 40% certain that it's in the left pocket, and 40% certain that it's in the right pocket. If key is not in the left pocket, what is conditional probability that it is in right pocket. So if it's L, probability of L is that it is in the left pocket, then probability of L complement would be that it is not in the left pocket. So probability of right would be, knowing that it is not in the left pocket, is going to be probability of right and left complement divided by probability of left complement. Now probability of right when it is not in the left is basically the same as probability of right. So it is probability of right divided by probability of left complement. So what is the probability of right? We know is 0.4, and probability of left is also 0.4, but probability of left complement is going to be 1 minus 0.4. That is going to be 0.4 divided by 0.6, or 2 out of 3. Question: coin is flipped twice. Coin is flipped twice. What is conditional probability that both flips land on head, given that both coin flips on head, given that first flip lands on head and B is at least one flip lands on head? So there is a B and a and a C. B is the probability of H and H. A is the first flip lands on the head, which is H, H, and H and T. And C is any flip lands on the head, which is H, 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 T, T, and H. So this is first flip on head. This is any flip on head. So probability we want to know of B, knowing A, is going to be probability of B intersection A and probability of A. So what is probability of B and A, which is probability of probability of B and A is basically the probability of B, which is both landing on head, which is going to be 1 by 4, and probability of A is going to be 1 by, or 2 by 4, or 1 by 2, so that is going to be 1 by 2. But if we think of probability of B and C, then you have probability of B and C divided by probability of C. Now probability of B and C, since B is both, that's going to be 1 by 4, but probability of C now becomes 3 out of 4, so that is 3 out of 4, so that is 1 by 4 times 4 by 3, so that is now 1 by 3. Next question is, Celine estimates the probability of A. Celine estimates the probability of A in French as half and probability of A in chemistry as 2/3. Let's just that be an F and that be a C. If Celine decides to base her decision on flip of a coin, what is probability that she gets an A in chemistry? So if she takes French, then the probability of getting an A is half. If she takes chemistry, then the probability of getting an A is 2/3. But whether or not she's taking French or chemistry is based on the flip of the coin. So if she does flip a coin like that, what is the probability that she will get an A in the chemistry? So probability of C and head getting A in chemistry and getting a head, getting A in chemistry and getting a head will be probability of C getting a head times probability of getting a head. Now what is the probability of C A in chemistry after hitting a head on the coin toss is going to be, first you get a head in the coin toss, that is 2, and then you get a C in the chemistry, that is 2/3. So probability of getting a C after getting a head is still just going to be 2/3, but probability of getting a head is 1/2. So that is going to be 1/3. The next question is, you have a urn with 8 red balls and 4 white balls. We draw two balls from it. What is probability that both balls are red? So you can do it as a combinatorial analysis, which is 8 pick 2 divided by 12 pick 2, or you can do it using a conditional probability formula, which is probability of R1 underscore R2. The first one and second one is going to be probability of R2, knowing that we have R1 times probability of R1. So probability of R2 after R1 would need to be, the probability of R1 is going to be 8/12, and R2 after R1 is going to be 7/11, and probability of R1, the probability of R2 after R1 is going to be 7/11, and probability of R1 is going to be 8/12. So you can get it that way also. The next question is that we have 4 strong teams in quarter final of a soccer tournament. Probability that they will not play with each other. So there are obviously 8 teams total, right? So there is a team A, B, C, D, and the other teams are E, F, G, and H. If Wi is equal to 1, 2, 3, 4 be the event that team I plays with one of the 4 weak teams, where W is an event that 1, 2, 3, 4 play with 5, 6, 7, 8, then W1 means that team 1 is playing with B teams, 2 means the W2 means the team 2 is playing with any of the B teams, 3 W3 means team 3 is playing with any of the B teams, and W4 means any team 4 is playing with any of the B teams. So then W1 and W2 and W3 and W4 will be, now this is the law of iterative probabilities. This is going to be probability of W1 times probability of W2 knowing W1 times probability of W3 knowing W1 and W2 knowing, and times probability of W4 knowing W1, W2, W3. So what would that be? The player, how would we know that what is the probability of W1 is playing is the 4 out of 7, because 1 the team is there, the total 8 teams to choose from, and 4 is the favorable, and then W2 would be, but because 2 teams have already gone out, so the only teams to choose would be 3. If W1 has already happened, that would be 3. And how many teams are there to choose from? Now the number of teams to choose from is going to be, one is that itself, and 2 teams are already left, so this is going to be 5. And then this one is going to be, it has only 2 teams to choose from, and this is going to be 3 now, because 2 teams are gone here, 2 teams are gone here, so that's left with 4 teams, and 1 is this team itself, so the teams to choose is going to be 3, and that is going to be this, so it is going to be 8/35.